Welcome back again, YouTubers. Uncle Pythagoras signing in. We are completing the question, the last part of the question from the KZN 2023 September question 3 of the projectile motion. The question wants us to draw the graph. The question says, on the same set of axes, draw a velocity versus time graph for the stone and the helicopter from the instant the stone is dropped until it hits the ground. Clearly show the following on your graph. Clearly show the following on your graph. This is what we need to show. One, you must show the initial velocity of both the stone and the helicopter. Two, the time taken for the stone to reach the ground. And thank you very much for those who have subscribed and liked my video. And I would encourage most of you to engage on this one. Right, here we are given. We know that our VI was given as minus 8 meters per second. Minus because it is going up. Remember, by the way, you must start off by reminding yourself, this is not for marking, this is for your own good to see as a reference point. Downward is positive. If you keep this in mind, then you will understand why you are going to have a V as negative 8 meters per second, because the helicopter was going upwards. So is the stone is going upwards. And what else do we have? We have calculated time as 6,34 seconds. This is what we have. Now, for you to draw this this graph, it's a velocity time graph. Now this is our velocity and this is our time. This is our velocity and this is our time. Our initial velocity is negative 8 meters per second. We must follow it as it is negative downward, positive upwards. 2, 4, 6, 8. This is your 8. Let's say this is 8, negative 8 meters per second. The time is 6,37. We are going to say 1, 2, 3, 4, 5, 6, 7. So 6.3 is somewhere here. 6,34 seconds. The helicopter is going to travel at a constant velocity of 8 meters per second. It does not go up or down. This is the helicopter on the air. This is our helicopter on the air. Then our stone is dropped at a certain height, which is not included because it's a velocity time graph. Then it goes excuse me. The stone travels where the motion of the stone meets the time, it's the ground. So this, we'll consider this as a ground. And then this ground, we must calculate the velocity at which the stone hits the ground. But that question is not included in this question paper. But I dare you, YouTubers, go and calculate the VF, and then you engage it with us when we come back for the next video to continue with it, to tell us what is the final velocity of the stone. Now, this is a helicopter. Then here is going to be our stone. Here is our stone is dropped from the height of h, which was given as, we have calculated as 146,7 meters above the ground. Here it goes, it reaches the ground. Then at this ground, what is the velocity? Now this is what they want you to do. They give you marks for VI to indicate that VI is going to be 8 meters per second, going up, negative. The time is 6,34 seconds, another mark. This is out of 4. Then another mark probably, I don't know, they will give you as per the indication of the stone. You indicate the stone, you indicate the helicopter. That's how you will do it. These questions, remember, this is parallel to the time axis. That shows that the ground and the time axis are parallel. Then the helicopter, if it was not constant, it wouldn't be parallel. It is parallel because it does not change. It goes like that forever at negative 8 meters per second. Negative means going up 8 meters per second. So if someone go and find the final velocity, then we'll take it from there. When we come back in the next video, if you did not get it right, then I'll calculate it for you to find the final velocity. That is all for today, YouTubers. Thank you very much for participating and engaging with us. And we will want to hear from your comments more. And then we ask you to like and subscribe, also to share the video. I thank you very much. I also thank those who have liked and subscribed and those who have commented. Thank you very much. Your input is highly regarded. Thank you very much. Uncle Pythagoras signing out.